Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris bin Effendi, and today, as a Group 5, we will present about Lab 3, Question 1 for subject ECE 521. Okay, for the first one, let's start with introduce our team members. The first one is me, Muhammad Haris. The second one is Adam Haikal, and the third one is Ahmed Zakari. We have worked together to complete this project and presentation. We will explain about result, coding, and also the objective of this project. The objective of this project to develop and execute C++ program using Arduino IDE for the Raspberry Maker Pi Pico microcontroller. Second is to verify the operation and timing performance of different LED and buzzer generated by microcontroller based on push button input. The third one is to interface the control to push button, a LED, and the piezo buzzer using GPIO input and output programming. This flowchart describes the control logic of LED and buzzer using two push buttons, switch 3 and switch 4. The system starts by analyzing LED button and a buzzer. It then continuously checks the button input. If both switch 3 and switch 4 is pressed together, all LED blink and the buzzer sound for 3 seconds. If only switch 3 just push, the odd LED blink for 1 second and the buzzer operate for 2 seconds. If only switch 4 is pressed, the event LED is turned off for 2 seconds and the buzzer sound 4 seconds. And after each action, all LED and the buzzer are turned off and the system returns to monitor the button for the next input.
Alright, this program is designed to control LEDs and a buzzer using two push buttons, SW3 and SW4. At the beginning of the program, all LED pins, push buttons pins, and the buzzer pin are declared. The LEDs are connected to GPIO pins 0 until 7, while SW3 and SW4 are connected to GPIO 20 and GPIO 21 respectively. The buzzer is connected to GPIO 18. When the system starts, the setup function initializes all LEDs as output device and turns them off. The push buttons are configured using input underscore pull up, which means this button will normally read high and change to low when pressed. The buzzer is also configured as an output and is initially turned off. Inside the loop function, the program continuously monitors the status of both push buttons. The first condition checks whether SW3 and SW4 are pressed at the same time. If both buttons are pressed, the buzzer produces a 1000 Hz tone while all LEDs blink repeatedly. The LED turns on and off every 100 milliseconds, creating a flashing effect for approximately 3 seconds before the buzzer stops. The second condition is activated when only SW3 is pressed. In this mode, the buzzer generates a 1200 Hz tones and only the odd number LED, which are LED 1, LED 3, LED 5, and LED 7, blink together. These LEDs stay on for 500 milliseconds and off for another 500 milliseconds. This blinking pattern repeats for about 2 seconds before the buzzer is turned off. The third condition occurs when only SW4 is pressed. The even number LEDs, which are LED 0, LED 2, LED 4, and LED 6, turn on continuously while the buzzer produces an 800 Hz tone. The LED remain on for 2 seconds and are then turned off. However, the buzzer continues to sound for an additional 2 seconds before stopping. Finally, if either SW3 nor SW4 is pressed, the program enters the default state. In this state, all LEDs remain off and the buzzer is silent. This ensures that no output devices are active when there is no user input. Overall, this program demonstrates the use of digital input, conditional statements, loop, LED pattern generation, and buzzer control to create different output responses based on the user button selection.
Okay, now moving on to the next slide. This slide is about result and discussion. When SW3 is pressed, all LED such as LED1, LED3, LED5, and LED7 would produce a complete blinking cycle of 1 second. The LED will turn off, but the buzzer continue producing a tone for an additional 1 second before stopping. So basically, the buzzer will turn on for 2 seconds. And then when SW4 is pressed, even LED such as LED0, LED2, LED4, and LED6 will light up for 2 seconds. The LED will turn off, but the buzzer continue producing a tone for an additional 2 seconds before stopping. So basically, the buzzer will turn on for 4 seconds. Okay, the next one, when both SW3 and SW4 are pressed, all LED will blink for 0.1 second. The buzzer will also be on for 3 seconds. Okay, so for the last one is conclusion. For this conclusion, this experiment successfully demonstrates the use of the Raspberry Pi 2350 based Maker Pi Pico for digital input and output programming. The developed C++ program correctly controlled the LED and buzzer according to the states and push button SW3 and SW4. The observed LED pattern and buzzer activation match the required specification, while measurement the program delays were accurate. Overall, the experiment enhanced understanding of GPIO, interfacing, timing control, and embedded system programming using Arduino IDE. Okay, that's all from us, Group 5. Thank you very much for your listening and hope you can see you later.